The greatest commercial use of oxygen gas is in the steel industry. Large quantities are also used in the manufacture of a wide range of chemicals, including nitric acid and hydrogen peroxide. It is also used to make epoxy, used as antifreeze, and to make polyester. Oxygen gas is used for oxyacetylene, welding, and cutting of metals. A growing use is in the treatment of sewage and effluent from industry. Oxygen first appeared in the Earth's atmosphere around 2 billion years ago, accumulating from the photosynthesis of blue-green algae. Photosynthesis uses energy from the sun to split water into oxygen and hydrogen. The oxygen passes into the atmosphere and the hydrogen joins with carbon dioxide to produce biomass. When living things need energy, they take in oxygen for respiration. The oxygen returns to the atmosphere in the form of carbon dioxide. Oxygen gas is fairly soluble in water, which makes aerobic life in rivers, lakes, and oceans possible. Oxygen makes up 21% of the atmosphere by volume. This is halfway between 17% and 25%. The element and its compounds make up 49.2% by mass of the Earth's crust and about 2/3 of the human body. There are two key methods used to obtain oxygen gas. The first is by the distillation of liquid air. The second is to pass clean, dry air through a zeolite that absorbs nitrogen and leaves oxygen. A newer method, which gives oxygen of a higher purity, is to pass air over a permeable Cural membrane.
In 1746, German chemist Andreas Marggraf figured out how to isolate zinc by heating carbon and calamine. 17% of zinc's annual production goes into brass and bronze. 17% is used in die casting. Helps create roofing materials, also chemical compounds such as zinc oxide, which is white powder that shows up in everything from sunscreens to solar cells to nuclear reactors, where it helps prevent corrosion. Essential mineral that keeps the body enzymes going. Some of the weirdest side effects of zinc deficiency involve abnormalities of smell and taste because the metal is crucial to these processes. Medical studies have found that if zinc lozenges or spray are used within 24 hours of the onset of symptoms, the length of a cold is reduced. Zinc is essential to life. Every cell requires zinc to multiply. Your body requires zinc to make white blood cells. Zinc is essential for healthy skin. It is a natural element found in every cell of your body, in the earth, in the food you eat, and in products everywhere. Zinc is the forefront of health research. Zinc is vital during pregnancy. It is essential for the developing fetus where cells are rapidly dividing. A zinc deficiency is implicated in deteriorating vision that accompanies the aging process. Zinc boosts brain activity. Zinc oxide has been used for years to soothe diaper rash and relieve itching. Zinc stimulates the transport of vitamin A from the liver to the skin. Zinc glucosinate lozenges, taken at the first sign of a cold, reduces duration and symptom severity by 42%. Insufficient zinc has been linked to anorexia, which responds well to zinc replacement treatment. Zinc abnormalities also often exist in mood disorder patients. Zinc is a vital nutrient. It stimulates growth, fights infection, and heals wounds. Zinc is used throughout the world largely to protect steel against rust. More than 5.2 million metric tons of zinc are consumed annually in the Western world. Zinc's unique properties allow it to be cast into an array of precision parts for automobiles, airplanes, and appliances. Gold is an element that was known to ancient man and has always been prized for its color. Here is a collection of facts about this important metal. Gold is a chemical symbol with AU. Chemically, gold is a transition metal, one of the least reactive metals. Because the Earth was molten when it was just formed, so almost all the gold in the early Earth sank to the planetary core. Gold can be dissolved by aqua regia. Gold is a highly valuable and sought-after precious metal for jewelry. and other arts since the beginning of recorded history. Gold is the most malleable of all metals. A single gram can be beaten into a sheet of 1 square meter, or an ounce into 300 square feet. Gold leaf can be beaten thin enough to become transparent. The transmitted light appears greenish blue because gold strongly reflects yellow and red. Such semi-transparent sheets also strongly reflect infrared light, making them useful as infrared shields in visors of heat-resistant suits, and in sun visors for spacesuits. Gold is a good conductor of heat and electricity and reflects infrared radiation strongly. Egyptian hieroglyphs from as nearly as 2600 BC describe gold, which King Tushratta of Mitanni claimed was more plentiful than dirt in Egypt. Egypt, and especially Nubia, had the resources to make them major gold-producing areas for much of history. One of the earliest known maps, known as Turin Papyrus Map, shows the plan of a gold mine in Nubia together with indications of local geology. The primitive working methods are described by Strabo and Diodorus Siculus and included fire setting. Large mines were also present across the Red Sea.
Potassium is a highly reactive metal. Exposed to water, it explodes with purple flame, so it usually stored under mineral oil for safety. Because it's so reactive, potassium isn't found free in nature, according to the Jefferson National Linear Accelerator Laboratory. However, minerals and compounds containing potassium are common. It's the 7th most abundant element in Earth's crust. Naturally occurring potassium salts such as saltpeter and potash have been used for centuries, but no one isolated potassium until 1807 when Cornish chemist Humphrey Davy had the notion to run an electric current through some wet potash or potassium carbonate. The current broke the bonds holding the compound together. Davy would later repeat the trick in order to discover sodium, according to the Chemical Heritage Foundation. Although potassium is the 8th most abundant element on Earth and comprises about 2.1% of the Earth's crust, it is a very reactive element and is never found free in nature. Metallic potassium was first isolated by Sir Humphrey Davy in 1807 through the electrolysis of molten caustic potash. A few months after discovering potassium, Davy used the same method to isolate sodium. Potassium can be obtained from the minerals. Pure potassium is a soft, waxy metal that can be easily cut with a knife. It reacts with oxygen to form potassium superoxide, and with water to form potassium hydroxide, hydrogen gas, and heat. Enough heat is produced to ignite the hydrogen gas. To prevent it from reacting with oxygen and water in the air, samples of metallic potassium are usually stored submerged in mineral oil. Potassium forms an alloy with sodium that is used as a heat transfer medium in some types of nuclear reactors. Potassium forms many important compounds. Potassium chloride is the most common potassium compound. It is used in fertilizers as a salt substitute and to produce other chemicals. Potassium hydroxide is used to make soaps, detergents, and drain cleaners. Potassium carbonate, also known as pearl ash, is used to make some types of glass and soaps and is obtained commercially as a byproduct of the production of ammonia.